Okay, last time I had started with this hierarchical clustering, okay, and I had taken one example also. So any doubt in this? Taken, last time I had told you that this hierarchical clustering is of two types. Okay, there are two approaches actually to perform this hierarchical. One was by using the bottom-up approach that I had taken, that is agglomerative. Another one is just the reverse of that, that is the top-down approach, that is called the divisive method. Okay. In agglomerative, what we assume, we first of all assume that each data point is a single cluster, and then we start joining them depending upon the minimum distances between the clusters until we get one cluster. Okay, so we are starting from one cluster and we will join them. Then there may be some clusters having two data points, then three data points, like this way it will go on. And we have to stop when we are getting one cluster. Then we need to find out that what is the optimum number of clusters that we have to take. Okay, that is the agglomerative approach. And in case of the divisive approach, we'll assume that all the data points, they are in one cluster, and we will split those. Okay, one cluster would be splitted into two, then two would be splitted into four, like this way it will go on. Okay, so I had taken last time this one agglomerative approach, and this is an example that I have already taken. Again, I'll just go through that. Suppose you are having these six data points. We'll assume 1 minute. Okay, we will assume that each data point is a different cluster. Okay, so how many data points are there? 6. So I will assume that there are 6 clusters. Then we will find out the shortest distance between them. Okay, like what is the distances between different cluster? Like what is the distance between this data point, this and this, between this and this, between this and this, and between this and this. Out of all the distances, I will tell you later on that how to find out the distances. Out of all these distances, I will take the minimum one. Suppose these two clusters are very close to each other, so we will combine that into one. Okay, now the number of clusters will become 5. First it was 6, now it will become 5. Okay, 1, 2, 3, 4, 5. Again, I will find out the distances between these clusters, and I will join the two clusters having the minimum distance. Suppose these two clusters are very close to each other, so we will combine them into one. Now the number of clusters again are reduced by 1. So number of clusters are now 1, 2, 3, and 4. Again, the same step would get repeated, and suppose the distance between this and this is minimum. Okay, so I will combine them into one. So this is your cluster. Okay, now there are 3 clusters. Now again combine them. Okay, suppose the distance between these two is coming less, so combine them. We are combining it, and next these two will be combined in one cluster. Okay, once you're getting one cluster, you have to stop. So this is actually the like the one step of your agglomerative, first step of that. Next step was that you need to make one dendrogram. Okay, then that dendrogram, from that dendrogram tree type structure, you can find out that what is the optimum number of clusters that you have to take. So I will take this again. So same example, I'm taking this one only. Okay, how many clusters were there? Starting there was 6. So over here you need to make one tree structure in which you are taking here data sets, that means data points, and over here you are taking the distance. How to find out the distance, that I will tell you later on, because there are many ways to find out the distances between different clusters. Okay, suppose the distances are written like 0, 5, 10, 15, 20, 25, and here are the data points. What are these data points? Now these are the data points. This is your P1, P2, this is your P3, P4, 5, and 6. Okay, so you can write down this is P1, 2, 3, 4, 5, 6. So first of all, we have joined P1 and P2. Okay, sorry, P2 and P3. So over here, you have to join the P2 and P3. That means 5 we are joining P2 and P3 because the distance between these two clusters was minimum as compared to the intercluster distances between another clusters. Okay, suppose the distances between P5 and P6, that is something, suppose 6, and over here suppose that is your 4. So I will take this one. So in order to join them, how much distance is there between them? Suppose that is your 5 according to this graph. Okay, so I will draw a line from P2 and P3, and the length of that would be 5. Why 5? Because the Euclidean distance between these two clusters, that was 5, and I will join them like over here. So it will be a structure like this. Is it okay? Next, now these two are joined in one. Next, again, I will find out the distances between different clusters. And now suppose the distance between P5 and P6, that is coming out to be something 5 point something. Okay, suppose it is around 5.3. So I will join them. Okay, P5 and P6. So again, I will make two lines from P5 and P6, and the length of these two lines would be, what is the distance between them? Suppose if it is 5.3, so around 5.3 till this point, you have to draw these vertical lines and then join them. Okay, so this is your P5 and P6. Okay, so just consider this one that I have now highlighted. One is this, another one is this. Okay, so these two things are showing that now the number of clusters. Okay, in the first step, the number of clusters were 1, 2, 3, 4, 5, 6. Now the number of clusters are 1. This is your 1. This is your now is representing one cluster because we have joined them. This is second cluster. This is your third. And this one is your fourth cluster. Now they are 4 clusters. Okay. Now again, you will find out the distances between these clusters. Okay. And suppose the distance between P1 and this cluster, cluster number 2, that is coming out to be around 9. And again, the distance between 3 and 4, that is coming out to be almost same, suppose 9. So what you have to do from P1, again, draw one line till this 9. And now this is representing one cluster. Okay, so you will draw a line from the center of this horizontal line. Okay, so from center of this, I'm drawing a line till 9. You don't have to draw a line over here. Just from the center of this, you have to start, and till 9 you have to draw. So this is representing your one cluster. Now it is representing, now you have joined P1 and this cluster, cluster number 2. Similarly over here, you are joining now P4, and you are taking the center of this, actually this cluster, the fourth cluster, and you are joining them. Right? So this is now how many clusters are there. Now you have joined them. This is one, and this is your second cluster. So one cluster is there and second cluster. Fine. Again, find out the distances between these two clusters. What is the distance between this and this? Okay, and suppose that distance is coming out to be around, suppose 27. So again, I will take a line from the center of this, and over here also from the center of this, and the length of that is till, suppose the intercluster distance was your 27. Okay, so you can join them now. Okay, so this is your dendrogram, how to create these rectangle type of structures. But how to find out now? We need to find out the optimum number of clusters. Now, in order to find out the optimum number of clusters, what I have to do? Okay, you need to draw some horizontal lines. Okay, but that horizontal line should not cross any horizontal bar. Like you can't draw a line like this way. You can't draw a line like this way. That horizontal line should cross all these vertical lines. Okay, so what I will do, I will draw a line. Now here you can see there are some vertical bars, and during this time from 0 to 5, okay, till this distance there is no horizontal bar. So I will draw a line. I'm drawing one line over here. Fine. Now you can see during this distance from suppose 5 to 9, there are some vertical lines, and there is no horizontal line over here. So I will draw a vertical line over here, and then I'm drawing a horizontal line, sorry. I'm drawing a horizontal line over here that is cutting these vertical bars at this point, over here, and over here. Okay, or you can say that when you have joined these two, there you can draw a line. Here you're drawing a line when you have joined all these, and then you have joined these clusters over here, then you are drawing a line, horizontal line over here. Next, out of these, now how many lines, horizontal lines I have drawn? 3, 1, 2, and 3. Now you have to check the distance or the height of the vertical lines that is being cut by this horizontal line. Now this horizontal line is cutting these lines over here. Okay, now what is the length of these? What length of these vertical lines? Okay, you can see over here the length of this is from 0 to 5. This length, this is 0 to 5. I'm drawing one rectangle over here. Now this vertical line is cutting over here. Now what is the length of the rectangle that you can create without cutting any horizontal bar? I can draw one rectangle over here, but it should not cut any horizontal line. I'm not able to draw it properly. You can say this one. Okay, then you should not cut these vertical lines that you have already drawn using these red lines. Okay, you can see this one. Okay, suppose what is the height of this? Height of this is 4. Height of this was suppose around 5. Now draw one more rectangle over here. You can see even this one is not including any horizontal red line. Okay, and what is the length of this? Around, like I can say 10 to suppose it is 27 or 25. If I'm taking, it is around 15. Length of this is around 15. Here it is 4, and here it is around 5. Out of these three, you have to check which one is having the maximum length. Maximum length means maximum distance kiska hai. Okay, maximum distance this is having 15. So I will consider this rectangle that is having, or in this case, the vertical lines are having the maximum distance. Okay. Now what you have to check, the line that you have drawn, how many lines it is cutting? It will cut 2 vertical lines. It is cutting this one vertical line and this vertical line. That means the number of clusters that you need to consider is 2. Optimal number of clusters that you have to take, that is 2. Is it clear? I'll take one more example in the next slide. This horizontal line, the blue one, you need to check that how many lines it will cut, how many vertical lines it is going to cut. It is going to cut 2 vertical lines. That means the number of clusters over here are 2 that you need to consider, because these 2 vertical lines are having the maximum height. Over here, if you are taking these one, okay, suppose this is my optimal one. Suppose these vertical lines were having the maximum length. In that case, you need to check how many lines are being cut by this blue line. 1, 2, 3, and 4. In that case, you will take 4 number of clusters. And if I suppose if I'm considering this one, this line, how many lines are being cut by this? 1, 2, 3, 4, 5, 6. In that case, the number of clusters would be 6. But right now, these vertical lines were having the maximum distance, and this is being this horizontal line is cutting actually just 2 vertical lines. So number of clusters that I have to consider is just 2. Okay, so that is the yes, Pawan, you are saying repeat. What I need to repeat? The whole thing?
Hello, good morning, ma'am.
Yes, you joined late.
No, ma'am, but ma'am, ये optimum number cluster वाला ये थोड़ा confusing था
Okay,
यार.
obviously confusing it. That's why I'm repeating it. But you need to tell me that till what point it is cleared, because I won't repeat the whole thing. Okay, till what point it was cleared. It is okay how to draw these red lines.
मैम जो blue वाली line है इस यहाँ से थोड़ा repeat कर दो please.
Okay, I will take the another example. Okay. This one, I'm taking this example, this one. Suppose already you have drawn these things, dendrogram. Okay, in that, Pavandeep, that was clear how to draw these. Suppose initially there were many data points and all these data points were having were considered one cluster. Then you started joining them. When you were joining them, you are getting a tree type structure like this. Don't take this one, the purple rectangles. This one is okay. The red lines are there, some blue lines are there. That is okay.
Yes, ma'am.
Okay, next what you have to do, आपको पवनदीप horizontal lines draw करनी है. Horizontal lines means it should cut these vertical lines, but when you are taking that horizontal line, it should not include these horizontal bars that are coming. Okay, ये जो horizontal bars है वो नहीं बीच में आनी चाहिए. Like suppose I can say I can draw a line over here. Just see, Pavandeep, this one, this is okay. I can draw this horizontal line because this horizontal line is not including any horizontal bar over here. Okay, और एक तो या तो है कि आप एक horizontal simple line draw कर लो पवनदीप, or if you are confused, what you can do, you can see now that this horizontal line is having this bar that is having the highest height over here, and this one. In between these two, you can draw one rectangle over here. I'm not able to draw the straight lines. You can assume this is one rectangle. Fine. Or you just assume that there is one vertical, horizontal line that is cutting the different lines over here. Then I can draw one vertical line over here that is cutting these vertical lines over here. Then you can see this one also because you are joining over here. So I can draw one vertical line through this. It's a very small rectangle. Then I can draw one horizontal line over here, and then one more horizontal line over here also you can draw, because here also you can see you can joining this and this one. Okay, this was one cluster, this was the second cluster, and then you have taken the center of this, and you are joining them. That means this is another cluster, one cluster that you are making. So one horizontal line you can draw through this also. Is it okay? Now, next thing is that we need to find out of these, which one is the optimal one. In order to find out the optimal one, you need to find out what is the height of these rectangles that you have drawn. Okay, here I have not drawn the rectangle. Suppose that rectangle height would be from this point to this point. Okay, so this is the height of this rectangle. When you're drawing this horizontal line or this rectangle, anything out of these two you can draw, you can see the height of this would be from this to this. That is the highest one that I can take. Next, if you are drawing one horizontal line over here, here you have joined this cluster and this cluster, the center of this one. Okay, this is having very small distance, small height is there. So this one, and over here, what is the height of this? This one. And over here, what is the height of this rectangle? This one. So you can check that all these rectangles, when you are drawing, they are not including any of these horizontal bars. These one, blue, red, green one, over here, this red one. Okay. So out of these four, what do you think? Which one is Pavandi? Which one is having the maximum height? Pavandi, इनमें से ये जो मैंने एरोज ड्रॉ की हुई हैं, इनमें से मैक्सिमम हाइट किसकी है? I will number them. I will number them again. Suppose this is 1, this is 2, this is your 3, this is your 4, and suppose this is your 5. I will number them again. Yes, now 1 की height तो बहुत कम है. You can say either 2 or 4. They are almost having the same length, no? Same height. Or you are saying 2. Okay, so that is fine, 2. Now, in the two rectangle, in this rectangle, when you are drawing one, now I'm clearing all other things. When you will draw one horizontal line within this rectangle, how many vertical lines it is crossing? How many vertical lines it is crossing? Yes, beta. Pavandip, you only have to tell me.
5.
1, 2, 3, 4, and 5. Okay, that means how many vertical lines it is crossing? 5. That means the number of clusters that you have to take, that is your 5. And suppose if you are taking this fourth one, here also you will draw one horizontal line. Again, check the number of vertical lines it's going to cut. You don't have to take this purple one, क्योंकि purple को चाहे dash बना लो, वो हमने खुद rectangle बनाई थी. Okay, you have to take these vertical bars. How many vertical bars are there? 1, 2, 3, 4, and 5. So it is cutting how many vertical bars? 5. So here also the number of optimal clusters would be 5. So if these two rectangles are having almost the same distance, then it doesn't matter that whether you are taking 2 or 5, 2 or 4. In both cases, you are getting 5 number of clusters. So that is the optimal number of clusters that you need to take. Is it clear?
Yes, ma'am. Thank you.
All others?
एक्सक्यूज मी मैम.
Yes.
मैम इसमें जो ये सेकंड वाला डिस्टेंस है, हम उसमें ये हमने खुद क्रिएट किया हुआ है, तो मैम फिर उसमें वो 3 वर्टिकल लाइंस को नहीं कट कर रहा?
1 minute, let me check over here. I will clear this thing. Yes, beta, yes. So over here, you are having this rectangle we had made actually, sorry. So these blue
Yes,
lines
ma'am.
were there. Yes.
मैम इसमें फिर 3 हो जाएंगे ना?
3, there will be 3. 1, 2, and this is the third one. So they are actually 3. Here it is actually 5.
Yes,
Na?
ma'am.
If you're taking 4, it is.
Yes, ma'am.
But over here you can see this is more as compared to this one. This distance is more
Yes,
as
ma'am.
compared to the fourth one. So optimal number of clusters would be 3. Pavandip, this rectangle we had created, na? Okay.
Yes, ma'am.
So don't take this one. These two red lines you don't have to consider. So that's why I had taken firstly this example that you don't draw the rectangle, you just draw the lines over here, horizontal line. This one, I'm doing suppose 1, this is second one, and this is the third one. That thing you can do. Okay. If you are confused, I will find out some more examples of this dendrogram. Otherwise, you find out some more examples from net. And if you have any confusion, you can ask me. Okay. Otherwise, I will do it.
ये कैसे एक डेंड्रोग्राम की जो करेक्ट आपने कहा ब्लू लाइन कट होएगी, मतलब 2 6 इसमें क्लियर हो गया.
Okay, next, this one is very important. Like when you are doing the, practically when you want to find out the clustering using hierarchical, you can set this, that how to find out the closest distance between different clusters. Now, in case of hierarchical clustering, there are different methods to find out the closest distance. Those are called your linkage methods. Okay. Now, what are the different linkage methods? There are mainly 4. First one is the single linkage. Okay. What is this single linkage? Suppose I'm having this cluster now and this cluster. In all other algorithms like in KNN, K means I had told you that whenever you want to find out the minimum distance between two data points, then we can take the Euclidean distance. That is okay. But what is single linkage now? Now you need to find out that what is the distance, minimum distance between these two clusters. Now, how can you find out the minimum distance between two clusters? For that, one method is single linkage. So in this single linkage, what we will do, the distance between two clusters is defined as the shortest distance between 2 points in each cluster. That means you will take one point in this cluster that is close to this one. You are having this point is closest to this cluster. Next, over here, you will take a data point that is closest to this cluster. this one. You will find out the Euclidean distance between these 2 points. Suppose that Euclidean distance is coming out to be 5. So this 5 will show you the distance between these 2 clusters. That is called the single linkage. Is it clear? Take one more example. Suppose this is R, this is S. You need to find out that what is the minimum distance between these 2 clusters. Now you can find out the distance between this point and all these data points. Okay, next you can do one thing, you can find out the distance between this point and all these data points. So actually we are finding the distances between each point over here to each point in the another cluster. But out of all these distances, which one you have to take? That is the minimum one. और वो minimum one कौन सा होगा? जो इस क्लस्टर में एक डाटा पॉइंट है जो कि इसके क्लोजेस्ट है, और इसमें जो एक डाटा पॉइंट है जो इस क्लस्टर के क्लोजेस्ट है, like this one. So you are actually finding the distance between these two. That would be the distances between these 2 clusters. That is okay. What is a single linkage? Yes, Ashley, is it clear?
Yes, ma'am.
Okay, next one is the complete linkage. Complete linkage method, if you are adopting, then what is that? It will find out that the distance between 2 clusters is dependent on the farthest distance between 2 points. That means you will take 2 data points that are having or that are farthest in these 2 clusters. Like this data point is farthest from this cluster, and this data point in this cluster is farthest from this one. You will find out what is the distance between these 2. Or in other words, again, what you are doing, you are just finding the distances between one data point to all other data points in another cluster, and out of all these distances, you are finding which 2 data points are having the maximum distance. That is called the complete linkage. Okay, so whatever is the distance between these 2 farthest points, that would be the distance between these 2 clusters. Whenever you are finding the distance between these 2 clusters, you can use this complete linkage method also. Okay, and like practically, if you will see some programs related to this on net, you can see that this is a most popular method to use, the complete linkage method. Okay, because here we are considering the farthest distance instead of the shortest one. So it will give you more tighter clusters in which the data points are close to each other. The third method is the centroid linkage. Centroid means from name only, actually it is obvious. You will find out the centroid of these. Centroid means the mean of all these data points. Suppose that mean is over here, then the mean of these data points, and you are finding the distances between the 2 centroids. That will give you the distance between these 2 clusters. Okay, and the next one is your average linkage. Now what we are doing in average linkage, we are taking, suppose this point, and we are finding what is the distance of this point from all the data points of S. Next, you are taking the next point, you are finding what is the distance of this from all the data points of S. Okay, that means you are finding the distances of all the data points, and you are dividing that by number of data points in this cluster and number of data points in this. That means total number of data points. That will give you the average linkage. Okay, so whatever you are getting, that is your distances between these 2 clusters. Suppose it is coming out to be, average is coming out to be something around 5.5. So that is the distance actually between these 2 clusters. Okay, so in average linkage hierarchical clustering, the distance between 2 clusters is defined as the average distance between each data point in one cluster to every point in another cluster. You are finding the average of that. Okay, so there are 4 methods to find out the distances between the clusters. So even this is important point in case of hierarchical clustering. Okay, suppose again some example is coming, like some question is coming, write a note on hierarchical First, I will take the algorithm. Within that, the first step was very important, that what we are doing, we need to make one dendrogram. Then you need to find out the optimal number of clusters. And then this also you can mention that how to find out the distance between the different clusters. Okay, single linkage method, or questions can be what are the different linkage methods. So linkage method is used to find out the distances between clusters. Okay, so if you have any doubt, you can ask me. Only 1 minute is remaining. I think this algorithm I will take next time again. This is very simple actually. Yes, beta. Any doubt?